So what I want you to do here is we're just going to take this graph and we're going to set it equal to 0. We're going to find the zeros. Okay, so 9x, and we're just going to set it equal to 0. So in this case, I can factor out a 3x, and that's going to leave me with an x minus a 3 equals 0. So 3x equals 0, and x minus 3 is equal to 0. Therefore, x is equal to 0, and x is equal to a 3. Okay, so those are going to be the zeros of the graph, right? Basically where the graph is going to cross the x-axis. So I'll say 0, and I will say a 3. Then now what we need to do is go ahead and use or check a test point to kind of see, like, is it going to be positive or negative? Because when we plug in a value between like these values here, if that value is going to be positive, then we can say the solution set is going to be positive. Like, that's going to make that true. So let's go ahead and pick some points. Let's do -1. Let's do +1, and then let's do 4. And let's go ahead and check it out, see what like works. Now, again, I'm going to go back now and plug these into this inequality. So if I do a 3 times -1 quantity squared, notice how I'm using parentheses. I think it's really, really important to make sure you're using parentheses. So therefore you don't make that mistake when you are simplifying it. So that's going to be 3 times -1 greater than or equal to 0. All right, so a -1 squared is going to be a +1. So that's going to be a 3. Plus 9 greater than or equal to 0. So that's going to be a 12 is greater than or equal to 0. So we can say -1 is going to be a positive, right? So sometimes we kind of look at this like that. Let's go and check out a 1. 3 times 1 comma squared minus a 9 times 1 greater than or equal to 0. That's going to be a 3 minus a 9, which is going to be a what? -6 is greater than or equal to 0, which is not true. So that is going to be a negative, and then let's go and check out a 4. So 3 times a 4 quantity squared minus 9 times 4 greater than or equal to 0. So that's going to be a 16. So 16 times 12 or 16, 32. So that's going to be 48 minus a 36 greater than or equal to 0. And you can say, hey, that's going to work. That's going to be 12 greater than or equal to 0. So that's positive. All right. Now, so therefore, hopefully you can recognize then that then graph the solution set. So hopefully you can recognize here that this graph is going to be positive from -infinity, right? It's going to keep on going all the way to 0, and then union all values from 0 to infinity. Okay, I'm sorry, not 0, 3. Because there's nothing happens from 0 to 3, right? So it's going to be 3 to infinity. Now, another way to kind of look at this, or what I always kind of like tell students, is like, this is fine. And this is very helpful also when you get to calculus. But I think also like in the fact of like, if you understand what this graph looks like, you should be able to graph this, right? So if you understand what the y-intercepts are, right, as we talked about a 3x times x minus 3, you could also graph this, right? We know that the a is going to be positive, so the graph is going to open up. So what I can do here is just say, I can do 0 and then 1, 2, 3. Right? Now, since a is positive, we know the graph is going to open up. And therefore, you could see that the graph is going to look something like this. So therefore, you can see, yeah, from -infinity to 0, the graph is positive. And then from 3 to infinity, the graph is also positive. And hey,